Henry flips a fair coin 3 times. The tree diagram below shows the possible outcomes. Use the tree diagram to answer the questions. What is the theoretical probability that Henry sees the same side on his second and third flip? So here that would be tails, tails. Tails, head wouldn't be the same. Head, tail wouldn't be the same, but head's head would be. Tails, tails are both the same. Tails, head is not. Head's tails is not, but head's head is. So that is 1, 2, 3, 4 branches out of 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Go ahead and complete number 2 and number 3. Describe 2 ways you could conduct a simulation of each situation. A. Vic is a basketball player who makes 5 out of 8 foul shots. What is the probability that he makes 2 foul shots in a row? So to describe the simulation, we can do a spinner with 8 sections, and then 5 of those sections would be labeled make, and the other 3 would be labeled miss. You could also do 8 cubes in a bag. You could do 5 of them are green to represent making it, and then the other 3 are a different color to represent missing. Then you would be pulling a cube out of the bag to represent whether the basketball player makes it or misses it, or spinning it to see if it makes or misses it. In the United States, about 6% of the adult population have type A blood, and about 7% have type O blood. What is the probability that at least 1 out of 5 randomly selected adults has either type A or type O blood? You could put 100 cubes in a bag. 7 of the cubes could be red for type O, and 6 of the cubes could be blue for type A. You would then need to pull 5 cubes from the bag, and a success would be when 1 of them came out as a red or blue cube. Another way you could do this is with pieces of paper in a hat. You could label 6 of the papers with type A, 7 of the papers with type O, and the remaining could be blank or some other letter. And then you would pull 5 pieces of paper out of the bag. One of them would need to be labeled A or O in order to count it as a success. Another way to conduct a simulation is with a random number table or a random digit table. The spaces in the list are not indicating a value of the numbers, but just that it's a way to organize it and keep straight where you are in the table when moving from one value to the next. So it says, describe how to use a random number table to conduct a simulation of the situation described in problem 1b. Describe the outcomes of the actual experiment. Define the numbers from the random number table that represent each adult in the actual experiment. The real outcomes would be the 5 adults and their blood types, which could be A, O, or a different blood type. to find the numbers from the random number table that represent each adult in the actual experiment. We could use the numbers 1 through 6 to represent A, since that was 6%. Then 7 to 13, 7, 8, 9, 10, 11, 12, 13 would represent O, because that's 7 numbers for 7%. And then you would have 14 through 99, including 0, 0, would be all other blood types. We're going to use 2 digits at a time instead of looking at 100. So when we look at 1, it should say 01, 6 should say 06, and 7 would say 07. We're going to collect 2 digits at a time. Then it says describe what one trial is for this simulation. A trial would be 5 sets of 2-digit numbers. Describe a trial that is a success and a trial that is a failure. A success would be at least one number between 0, 1 and 13. And a failure would be all values in the list of 5, because remember we're doing 5 sets, are 14 to 99 or 0, 0. In your book, you do have a random number table or a random digit table. Actually, it may not be in your book. It may be something that your teacher will print out for you. In my book, it's on page 204. When you're using this table, you don't want to ignore any numbers. You want to use all of the numbers in order. So if you come to the end of a line, you're going to pick up where you left off. And then the gaps, you're going to use the values to bridge the gap as well. So here is an example of a list of random digits, and we're going to use it to show conducting 3 trials. So I have 2 numbers, and we're doing that 5 times, and that would make 1 trial. Then we're going to do another set of 2 5 times. And that would be the second trial. Then repeat that for the third. So we'll look at whether we have a success. And here, are there any numbers that are between 1 and 13? Well, there's 5 and 5, so this first one is a success. Here I have a 13 and an 8, so that second one is a success. But this one doesn't have any values between 0, 1 and 13, so this one would be a failure. You are going to use that random number table that your teacher provides for you to conduct 15 trials of the simulation described in problem 2 and record your results in the table. Keep in mind that you can start at any place in the random number table, but you have to go from there. You can't skip around after that. So let's pick a place to begin. Here I had 48, 3, 16, 94, and 40. We'll write all those in our trial results. The number of adults with type A blood, those are 0 to 6, so that 3 would count as 1. And then type O would be 7 to 13, which we didn't have any. And then other would be 4. So is that a success or a failure? That one is a success. Now we need 5 more sets. We have 18, 90, 41, 12, and then 55. There aren't any from 0 to 6, or from 1 to 6, but there is one from 7 to 13, that 12 there. That is a success. 7, 38, 29, 94, and 04. So we had 1 from 0 to 6, or from 1 to 6, 1 from 7 to 13, and 3 others, so that is also a success. And then we jump right down to the next line. 19, 87, 64, 24, and 84. None of them were from 1 to 6. None of them were from 7 to 13. All of them were other blood types, so that one is a failure. 06, 75, 52, 22, and 28. There is 1 from 1 to 6, none from 7 to 13, and 4 others, which is a success. And in the next one we had 91, so that'll go in row 6. 97, 76, 24, and 70. There aren't any from 1 to 6 or any from 7 to 13, so that one is a failure. Continue working through your random digit table to fill in the remaining trial results and whether it was a success or a failure. Here are the results from my trials. And then we're going to use these to answer the following question. Since you're doing this independently, you will not have data results from your classmates, but we can use the results we have here. It says to use the results from problem 4 to combine the trials from everyone in your group. We are just using our own. What was the total number of successes and what was the total number of trials? So we're counting up all of those successes. And I had 1, 2, 3, 4, 5, 6, 7, 8, 9 successes out of 15 of our trials. Then it says to use the number of trials and successes to estimate the theoretical probability that at least 1 out of 5 randomly selected adults in the United States has either type A or type O. That is 9 out of 15, which if we were to change it to a decimal would give us an approximation of the theoretical probability, and that is 0.6, or roughly 60%. You and your friend are both going to the park. You will each arrive between 1 p.m. and 2 p.m. and remain for 15 minutes. This is the problem we opened up to yesterday. What is the theoretical probability that you and your friend will be at the park at the same time for at least a minute? Describe a trial for your simulation. So we can use a pair of 2-digit numbers between 00 and 59. So then we have 00 to 59 would represent the time between 1 and 2 p.m. Since there are 60 minutes in an hour. And we're going to ignore any numbers that are 60 to 99. Describe a successful trial for your simulation. We're going to find the difference between the 2-digit numbers, and then the trial is a success if it's less than 15. Because that would mean it overlaps at some point within those 15 minutes. If the difference between our 2 digits, or our 2 values, is less than 15, it is considered a success. So conduct a large number of trials, create a table to record your results, include the trial number, the random numbers from the table, and whether it is a success or not. We want to do a large number of trials, so the more trials we do, the better our results will be at indicating the theoretical probabilities. So here we go. Pick a spot. 32. Remember, we're skipping anything that's bigger than 60. And 00. The difference between those is 32, so that's a failure. Then we've got 12 and 51. The difference between those is more than 15 if I subtract. So that's a failure. 64 is bigger than 60. 95, 77. Oh, 32, that one would work. 94 does not. 86 does not. 48 would work. If I subtract 48 from, or 32 from 48, that gives me 16, but it's not less than 15. 94 we ignore, 77 we ignore, 22 we can use, and 12 we can use. If I subtract those, that's only a difference of 10, so that is a success. 44 I can use, 63 I cannot, 00 I can. 44 minus 0 is more than 15. 56, 1, if I subtract those, that's more than 15, so that's a failure. 17 I can use. 73 is too big, 69 is too big, 63 is too big, but 12 will work. 17 minus 12 is within 15 minutes, so that's a success. 35 I can use. And 10 I can use, but that difference is more than 15, so that is a failure. 30 is usable, and 55 is usable, but that's a difference that's more than 15. 44 I can use. 93 I cannot. 70 is too high. 3. The difference between 44 and 3 is bigger than 15. So it's a failure. 46 can be used. 67 is too big. 45 can be used. That's a difference of 1 minute, so that would be considered a success. 22 and 49 can be used, but that difference is more than 15, so that's a failure. I can use 20. 63 is too high. 85 is too high. 4 would work. The difference between those is 16, so that's too high. That's a failure. 26 works. And 48 works, but the difference between those is more than 15. Here I have 3 and 16. The difference between those is within 15, so that is a success. You can continue going with more and more data to get better and better results, but I'm going to stop here for the sake of time. It says use the results of your simulation to find the empirical probability that you and your friend will be at the park same time for at least a minute. I had 1, 2, 3, 4 successes out of 15. 4 divided by 15 is 0.26 repeating, so that can round up to 0.27. And it says combine the results from everyone in your group to use them to find the empirical probability. Again, we don't have anybody else's data to use, so that would be something that you could do in class, but we don't have that ability to do here. If we did, we could say something along the lines of how many total times we did the experiment as a class and how many total successes we experienced, and write that as our theoretical or our empirical probability. And that takes care of lesson 10. If you are in class, it would be helpful to use that data as it's going to get you closer and closer to the theoretical probability.